Welcome back to our asynchronous video series. This is AW 2.5, I believe. Today we are going to be talking about non-unit circle values. Yes, that's correct. We spent all that time developing and building the unit circle just to leave it behind. But we are going to use those same concept we used to think about the unit circle, even for a non-unit circle. Let's take a look at today's example. So here it is. Find the exact values of all 6 trig functions, sine, cosine, tangent, cosecant, secant, cotangent, for the point -5, 12 on a circle centered at the origin. Now, of course, our first step needs to be visualizing said circle. Forgive its lopsided nature. And if the point was -5, 12, that puts me in quadrant 2. I can estimate about right there where my x value was -5, my y value was 12. And just like we did with the unit circle, to figure out these trig values, we need to visualize the triangle there. So this would be the point where x was -5, y was up here almost to the top at 12. And this right triangle is the thing we need to be picturing. It's a right triangle, right 90 degrees. And the angle in question here would be this angle. So even though we're not on the unit circle, and hopefully we can remember that this unit circle has a radius of 1, and clearly here that radius or hypotenuse is not 1. On the unit circle, the reason it's so special is because the cosine value is the x-coordinate of a point, and the sine value is the y-coordinate of a point. That's only true because the radius is 1, because the hypotenuse is 1. In this situation, our very first understanding of trig, sine as so, or as so, and cosine as ca, and tangent as toa, those definitions are still true. The difference here being that our hypotenuse is something else. We can see that this adjacent side would be -5, this opposite side would be my y value of 12, and we would need to do some Pythagorean theorem to find out what is the hypotenuse. So you can do that. Pythagorean theorem it up, a squared b squared c squared. Or maybe you recognize your Pythagorean triples and you know, or you calculated, that the hypotenuse would be 13. So, like I said, we're actually going to go back to basics with SO, CA, TOA to say that 12 would be the opposite side, -5, the adjacent side, and 13 is the hypotenuse. Now, be careful with this -5. We, of course, know you can't actually have a negative length, but we do need to keep in mind that the x is negative when we're in quadrant 2, that the cosine is negative when we're in quadrant 2. And we'll take a look at how that plays into finding our trig values. Of course, we know sine opposite over hypotenuse. So the sine of our angle is simply 12 over 13. That's great. The cosine of the angle is adjacent over hypotenuse. Now, adjacent as a side is technically not negative because you can't have a negative length, but we're suspending that theory as we look into quadrant 2. In quadrant 2, we know that x is negative and the cosine value for this angle would also be negative. So being careful that even though we used it, consider it a 5, +5 in terms of the side, in terms of the cosine or other trig values, this is actually a -5. And that leaves us with tangent to find. Still going back to tangent's definition is opposite over adjacent, which would be 12 over, again, a -5. So the tangent here would also be, what did I mess up, you guys? Adjacent over hypotenuse. My bad, y'all, my bad. Hopefully y'all were watching. Hopefully you were watching and just squirming because I messed up. All right, so we've got adjacent over hypotenuse for my cosine, opposite over adjacent for my tangent. Which makes finding those reciprocal values, cosecant, secant, cotangent, Pretty straightforward and quick. Cosecant as the reciprocal of sine would simply be 13 over 12. Boom, flip it. Secant as the reciprocal of cosine would be negative 13 over 5. And tangent as reciprocal, which is cotangent, would be negative 5 over 12. So that's it. We have taken what we know and used to build the unit circle to continue finding more trig values even on non-unit circles. So let's keep it short and sweet and jump to your asynchronous assignment for today. All right, so pretty similar. Find the exact values of all 6 trig functions. This time the point is 2, -3. A few words of caution. Please keep your answers exact, meaning I don't want rounded decimals, I want exact values. So square roots, even better if you can do simplified square roots. If you want to take an extension, look that up. Square roots in our answers and also rationalized denominators. Please do not leave any square roots in the denominator of your answers. That's it. As always, I look forward to seeing your work. Please let me know if you have any questions. Good luck.